Our today's topic is resistance or electric resistance as we call it. In my previous lecture, we defined resistance as the total hindrance that is offered by a conductor to the flow of current. It is also defined as the ratio of potential difference across the conductor to the flow of electric current, and it is represented as R is equal to V divided by I, where V is the voltage and I is the electric current. Now today we are going to discuss what are the factors on which the resistance of a conductor depends. Generally, we say that resistance depend upon the four factors. These are the key four factors on which the resistance of a conductor depends. One is the length of the conductor. That means how long a conductor is. Second is the area of cross section of the conductor. Area of a cross section of a conductor means that how thick a conductor is. What is the thickness of a conductor? That means the area of cross section of a conductor. Third is the nature of the conductor. This means what type of a conductor we have. This means whether we have a conductor made up of iron or we have a conductor made up of copper. So actually, what is the nature of the conductor? What is the material that has been used to make the conductor? Whether it is a conductor of iron or copper or whatever material it may be made of. Fourth and last one is the temperature of the conductor. It simply means what is the temperature of the conductor. These are the four key factors on which the resistance of a conductor depends. One is the length of the conductor. Second is the thickness of the conductor or cross section or area of cross section of the conductor. Third one is the nature of the conductor, and fourth one is the temperature of the conductor. Let us see each one of these in detail. First is the length of the conductor. Resistance of a conductor, if R is the resistance of a conductor and L is the length of a conductor, then resistance is directly proportional to the length of the conductor. This means greater the length of a conductor, greater will be its resistance. This means if we take a conductor which is very large in length, then the resistance of that conductor will be much higher compared to a conductor that is smaller in length. Suppose we have two conductors. This is conductor 1 and we have a second conductor which is smaller in length, conductor second. Say this is conductor 1 and this is the conductor 2. Since the length of a conductor 1 is longer than the length of a conductor 2, the resistance of conductor 1 will be higher than the resistance that is offered by conductor 2, because the resistance is directly proportional to the length. Directly proportional means greater the length, greater will be the resistance. So this is the first. Resistance is directly proportional to length. Hence, the resistance of a conductor first will be greater than the resistance shown by conductor second, because resistance is directly proportional to the length. This is the one point. The second point is resistance also depends upon the thickness of the conductor. How much is the area of cross section of the conductor? Suppose if we have a conductor then thickness, this is the thickness of the conductor. It is also called area of cross section of the conductor. If this area of cross section of a conductor is A, then resistance R is inversely proportional to the area of cross section. resistance R is inversely proportional to the area of cross section. This means if the area of cross section will be higher, resistance will be lower. If the area of cross section will be lower, resistance will be higher. These are inversely proportional. Inversely proportional means if we increase the one, the second quantity will decrease. If we increase the area of cross section, resistance will decrease. If we decrease the area of cross section, the resistance will increase. These are inversely proportional. Area of conductor of cross section of conductor is inversely proportional to its resistance, whereas resistance of a conductor is directly proportional to the length. This means if we have two conductor, conductor A and conductor B, the thickness of conductor B, as you can see from the slide here, is more than the thickness of conductor B. Since resistance is inversely proportional to area of cross section, this conductor A has a larger area of cross section, so its resistance will be lower. Conductor B has a smaller area of cross section, its resistance will be higher because resistance is inversely proportional to the area. So thicker the conductor, lesser will be the resistance offered by it. Thinner the conductor, greater will be the resistance offered by it. So we have two equations here. One is resistance is directly proportional to length. Second is resistance is inversely proportional to area. We have two equations here. Resistance is directly proportional to length and resistance is inversely proportional to the area of cross section of the conductor. In the last lecture, I said if we replace the proportionality sign by equality sign, then we have to introduce a constant. Here, if we remove the proportionality sign by equality sign, then we have to apply the constant here. So resistance will be equal to constant into length divided by area. Resistance will be equal to constant C into length and inversely proportional to the area. We can write it like this. Resistance will be directly proportional to area and inversely proportional to length and inversely proportional to area. If we increase the length of the conductor, resistance will increase. If we increase the area of the conductor, resistance will decrease. Now this is a constant here. This constant is called resistivity. This is called resistivity and it is shown by a symbol P. It is shown by a symbol. This is a symbol and this symbol is called rho or H. Rho is the symbol of resistivity. Now this is the equation. Resistance is directly proportional to length of a conductor and resistance is inversely proportional to area of the conductor. And this rho is the constant. It is also called a resistivity. So R is the resistance. This is called rho resistivity. L is the length of the conductor and A is the area of cross section of a wire. Resistivity, which is denoted by symbol rho, actually denotes the nature of the conductor. So resistivity varies from conductor to conductor. Resistivity of if a conductor is a very good conductor, it allows a large magnitude of electricity to pass through it. Its resistivity will be lower. If the resistivity of a conductor will be very high, it will not allow the flow of electricity to pass through it in a very large magnitude. For example, if you take the insulator that do not allow the electricity to pass through it, say a rubber or glass, then the resistivity will be very high as compared to the resistivity of copper and iron or aluminum that actually allow the electricity to pass through them. So resistivity is actually the representative of the nature of the conductor. So it represents the nature of the conductor, this resistivity. So I will write the equation here again. This R is equal to rho into L divided by A. So here are the three factors. L is the length of the conductor, so R is directly proportional to L. If you increase the length of the conductor, resistance will increase. A is the area of cross section of the conductor. If you increase the thickness of the conductor, the resistance will decrease because it is inversely proportional to the area. And rho, it represents the nature of the conductor. It is the third factor on which the resistance depends. So resistance will depend upon the nature of the conductor, whether the conductor is made up of copper or conductor is made up of iron or glass or rubber. It depends upon the nature of the conductor, and this rho represents the nature of the conductor. These are the three factors on which the resistance depends. One is the nature of the conductor, that is represented by rho. Second is the L, length of the conductor, and third one is the area of the conductor. And the fourth factor that we have not discussed yet, that is the temperature of the conductor. And this resistance is directly proportional to the temperature of the conductor. That means if the temperature of the conductor will be higher, then the resistance will also be higher. If you cool down the temperature, if the temperature of the conductor will decrease, the resistance will also decrease. This is the fourth factor. So you have to remember that resistance depends upon the four factors. One is the length of the conductor. Second is the area of cross section of the conductor. Third is the nature of the conductor, and fourth one is the temperature of the conductor. As we already discussed, that resistance is directly proportional to the conductor. You increase the length of the conductor, the resistance will increase. It is inversely proportional to the area of the conductor. That means if you increase the area of the conductor, resistance will actually decrease. And it also depends on the nature of the conductor, that is called resistivity, and it denoted by symbol rho. And fourth one is the temperature of the conductor. If you increase the temperature of the conductor, and the resistance will increase, because resistance is directly proportional to the temperature of the conductor. Here is the summary. Resistance depends upon four factors, viz. Nature of conductor, which is also called resistivity and denoted by symbol rho. Second is the length of the conductor. The resistance of a conductor is directly proportional to the length of the conductor. Third is area of cross section of the conductor, and you know that resistance is inversely proportional to area of cross section of the conductor. Fourth one is the temperature of the conductor, and resistance is directly proportional to temperature of the conductor. Resistance is directly proportional to the length of conductor. Resistance is inversely proportional to the area of cross section that we already discussed. Resistance is directly proportional to temperature. And resistance depends upon the nature of the conductor and is called resistivity, denoted by symbol rho. This is all about resistance and different types of factors. Precisely, there are four factors on which the resistance of a conductor depends.